So it's a pleasure for me to be here. Thank you very much, Gilbert, for inviting me to this presentation. And I can promise you it will be an interesting session that all of us will be able to take with us and assure stronger cybersecurity to our organization. So the session today is called Maintaining Secured Operation in ITOT Converging Environment. So the name of this presentation is somehow suspecting if indeed the networks are being converged, or it is just the name of the presentation, and this is what I want to explain today. So a brief introduction on my activity. As I was introduced, Daniel Ehrenreich. I'm in the industry about 45 years, worked with many international and worldwide companies. I had the opportunity to visit quite many countries in Africa and supporting electricity and water organizations to improve the automation. In the past 6-7 years, I'm primarily dealing with industrial cybersecurity. And this is very important because we all know that protecting our industrial operations is very, very important. When we are speaking about industrial operations, it's not like IT. In the IT, we have banks, we have credit cards, we have government databases. In industrial operations, we are worried about electricity generation and distribution, water and sewage, oil and gas, chemical plants, food and beverage plants and factories, even building management systems, building control, cellular communication, wide range of manufacturing facilities, and finally public safety and smart cities. So when you are thinking about all these vertical activities, you need to start already be worried, because all these vertical applications can be attacked. And we only know 3 possibilities. Some people say 2 possibilities, I say 3 possibilities. One possibility is that your organization or a private person was already attacked, and from now on they are protecting better their operation. The second possibility is that the attack already started. The attacker is already in your facilities, in your computers, sitting there and day and night collecting information, and you don't even know about it. So this is a very risky situation. You know, think about somebody is already entered to your house or apartment, and you don't know that he's there 24 hours a day. And the third possibility, which most of the organization and people are belonging to, is that attack might happen as soon as tomorrow morning. So what we learn about what I explained about the three possibilities and the series of applications that I'm presenting here, that we need to start to worry not tomorrow, not next week, as soon as immediately. We need to be worried, and we need to ask ourselves a question: what are we doing to protect our organization and our facility? And this is very, very important. So I'm not going to bring you the slides which are showing thousands of attacks which are happening worldwide every day. I want to show you a short list of attacks specifically against industrial facilities. And I can tell you that majority of the attacks happened during the past 10 years. And the first major attack was the 2010 Stuxnet, when the Iranian nuclear facility was attacked. Then a couple of others, that's the steel plant, power utility in Ukraine, and other power utility in Ukraine. A major attack in Saudi Arabia, a high-risk attack. Luckily, nothing happened there. It was attack against safety instrument system. Then in 2019, we had the attack against aluminum factory. It was a very interesting attack because it was a ransomware attack which did not affect the industrial operation. However, due to the reason that the IT operations suffered the ransomware attack, the production could not be managed as it was expected. Then we had the water attack in Israel on one of the water utilities. Again, luckily nothing happened because the system was protected. Earlier this year, in February, we had the attack on a water utility in Florida, USA. Again, luckily nothing happened, but here, because the operator was on alert, detected what happened, and immediately took an action which corrected the situation. Finally, the attack which happened just recently, the Colonial pipeline, it was again a ransomware attack against the pipeline operation. So not an attack against operational technology facility, but an attack against IT. But again, the supply shut down mainly because the supplier didn't know how he's going to charge the customers if the IT operation is not working. So from this you can learn a broad range of attacks, and all of us must be worried and take immediate actions to correct the situation. When we are speaking about who are the attackers? So in the past, on the left side, we were talking about hackers. They could be young people operating from the bedroom. They didn't have an intention to cause damage. They just wanted to show their friends, see, I'm smart enough that I could do it. However, things changed. And today we are talking about cyber warriors, like soldiers. They are professional. They are financed by crime organizations and hostile countries. They are using advanced methodology, advanced tools, and finally they are successful. The goal of attacks against industrial operation is stealing information, critical information, cause operation outage and damage. But it can even be worse, because in the severe cases, attack may influence lives of people. And when lives of people are under attack, then we really need to worry about it. Even more worry than we are worried about damages. So let me show you a very simple picture. So simple that all of us can understand it without any major background. Here we see a triangle of an organization. In the bottom three levels are the industrial operations, operational levels, control and automation level, and in the floor we have the machinery. So you can see on the right side the instruments and the appliances which are involved, and in the top you see the IT organization. Until 2010, until the Stuxnet, for security purposes, the IT organization was completely isolated from the ICS operation. Completely isolated. So, but when the Stuxnet happened, which was an internal attack, somebody penetrated to the actual operation facility, people suddenly realized that the air gap is not helping them. So after 2010, organizations started securely and safely connecting the IT network and the ICS network. What is very important to mention here, related to the title of the presentation, that the IT network and the ICS OT network are not converging. They must not converge. And anybody who is using the term ITOT convergence is practically misleading the people and causing high risk and damage. We are not supposed to say IT-OT convergence. What is really converging, and this is okay, is the data. What does it mean converging the data? That information from the industrial facility is flowing up to the IT operation. So the people who are sitting in the IT operation, they have real-time knowledge about the production process, the need for raw material, the maintenance problems. So collaboration can happen because the people in the IT section have all the real-time information about what is happening in the industrial facility, and they can immediately react correctly. So repeating again, and I will come back to that again several times, the IT network and the ICS network are not supposed to be directly connected, not supposed to converge. However, the data is integrated together to achieve operating productivity, reliability, and so on. So this is, I wanted to explain it very, very clearly so everybody will understand it. When we are speaking about cybersecurity attacks, practically we hear so much information on the news, but in reality, there are three possibilities only, or three main possibilities. The first one is the internally generated cyber attack. When somebody is penetrating to the industrial facility, somebody is capable of inserting a USB or inserting a malvertised device to one of the computers or one of the controllers. By the way, this has happened in the Stuxnet attack in 2010. Exactly this is what happened. The second option I want to highlight is the externally generated cyber attack, and this is usually starting via the internet. Exactly what happened in Ukraine when the power utility was shut down. And not be surprised that the attacker might sit in your organization 100 to 200 days before he is detected. So what the attacker is doing during these 100 to 200 days, he is practically collecting information, transmitting the information to the attacker, and the attacker can create stronger attack sophistication. Finally, I would like to talk about the supply chain cyber attack. Supply chain cyber attack is what happened at the SolarWinds a couple of months ago. And here, the attackers are not only attacking a single organization, they are attacking the suppliers of the software, the suppliers of the hardware. So what is happening? You are buying a computer from the local distributor or an industrial controller, and suddenly the malware is already there. It's already installed. You bring that device to your organization and suddenly the entire organization crashes. Furthermore, we are talking about the remote access, remote connection, and this is very much true during the COVID-19 period. Why during the COVID-19? Because we are living in the situation that experts cannot travel to the facility and they cannot do the service, and we need to allow remote connection. So there is nothing wrong if the expert is connecting, but if an attacker identify how the expert is connecting, and on that night or day he can do the same access approach, he might be able to penetrate to the facility and cause a severe damage. Furthermore, I would like to show you a not too complicated picture, because in this very short presentation, obviously I cannot show you everything, but you can see here the organization. On the right side, you see the IT operation, the business corporate network, and you see the attacker is already sitting there and he's already planning his attack. In this end, and he's compromising the firewall and capable penetrating to the IT organization. When he's sitting in the IT organization 100 to 200 days, he has enough time to compromise the second firewall, which is segregating between the IT organization on the right side and the ICS organization on the left side. So, when he is managing to penetrate to the ICS organization, he will be capable identifying the specific controller, the specific PLC, which can be compromised, and then explosion can happen, huge damage, and maybe even risk to lives of people. So let me show you another simple picture, but the picture which should make you highly concerned, because you can see here the layers of the defense and the stages how a major cyber attack is developing. Initially, in the green box, everything is fine. The parameter is within the normal level. It can go up and down and nothing wrong. However, if anything happens, it can be a malfunction, it can be a failure, it can be a cyber attack. The parameter is going to higher level, like what happened in Florida in the old smart water utility. And now we have an unusual condition. If the operator is capable intervening, he will take action and the parameter will go back to the normal green box. However, if the operator is not there, or it happens during the night when he's sleeping, or he's unable to detect the situation, that parameter will go further and enter to the dangerous area, and you need to have a safety layer, a safety layer which is supposed to open the pressure valve or shut down the supply of gas or anything that it's really an instant action. Usually it should be a hardware type device. You don't want to rely on any software when you are reaching to the safety layer. You want something simple but effective, like a pressure valve which will open and the water can go out or the pressure can go out and all will be good. However, if somebody compromised that safety layer, any kind of sabotage, that parameter may go higher and higher. And if you are dealing with truly high-risk plants, you should probably have additional safety layers. However, if these safety layers are not functioning, finally, no choice, there will be an explosion, and I want to say even a bad explosion. So how can we protect our organization? The organization can be protected with multiple activities, and we call this protection PPT. Why PPT? Because we need to deal with people, policy, and technology. So every cyber defense, simple, complicated, inexpensive or expensive, not sophisticated or sophisticated, must be done according to the PPT triad. I put intentionally the people factor on the top. Why? Because 90% or 80% of the successful cyber attacks are happening because people did not receive training. And you must remember that people did not receive training. So training and drills and monitoring of personal behavior, compliance to policy are very, very important. The second factor is the policy adherence. Organizations must create policies. It must be documented, it must be enforced, and it must be supervised, enforced, yes. And auditing must be done maybe once a year, maybe twice a year, as much as you can afford it. And only finally, I'm talking about technology, because technology upgrades are always expensive, like modernization, updates, and maintenance. So this is the PPT triad. I want you to remember the ISO 27001. Section 5, para 1, top management is responsible for cyber security. Very, very important. So those of you who are managers in the organization, CEO level, president level, you need to know that cyber security is responsible of the top management. So let's go and talk about how are we protecting our organization, because we already know that the system is working around the day and we must assure a normal operation. We need to take 3 actions to protect our organization. First of all, the incident response. You need to have a team which was correctly trained, to take action when a cyber attack happens. By the way, it not have to be a cyber attack. It can be a major failure of components or some mechanical damage, but it is already an incident. So you must have a trained team. Furthermore, they must practice that process. The second action is business continuity preparedness. What does it mean, business continuity preparedness? You need to have alternative facility for controlling the organization. You need to have spare computers, spare process controllers. You need to be ready that something can go on. And again, you must inspect this preparation because every organization must assure business continuity. Finally, we are talking about the disaster recovery. Disaster recovery is also something that you need to be prepared or plan for that, and you need to know exactly what your team is going to do in order to correct the situation and as soon as possible bring back the organization to business continuity. So as you see, we are progressing through via truly easy to understand slides, and definitely these slides, if I didn't say it in the early stage, these slides are available for you. Please make sure that you receive the copy of these slides so you can share it with your organization and people can look at it, people can ask questions. So why is handling an industrial OT defense difficult? For many reasons. Because typically we are using outdated hardware and software, legacy type products. Easily you can find the equipment which was installed 10, 20, 30 years ago, no surprise. You cannot interfere with the process. This plant is working all the time. Any intervention like penetration testing or inspection may cause a huge damage and you need to be careful. A major problem. Don't feel bad if you have that problem because it is happening around the world. Most the cyber experts do not have a background. IT people do not have a cyber ICS background, and ICS people do not have cyber security background. So major gap which require education. People must learn. We all know that water companies, electric companies, manufacturing plants are working around the clock, 24 hours, 7 days a week, around every day, the year, and so you cannot stop them for maintenance. So what can you do to be creative and deploy external complementing and compensating measures? So coming back to the convergence, I already talked to you that convergence among the network is not allowed because the IT network is connected to the internet and the ICS network must be strongly protected. But we talk about converging of data. Data must flow from the ICS operation to the ICS operation in order to improve productivity, allow better planning, and better maintenance. Maintenance is very, very important. If all the information from the plant, it can be water, electricity, oil and gas, food factory, chemical plant, so and so on, according to list I showed earlier. If we are passing all this information, then obviously all will be fine. So as I said, data must flow from the ICS to the IT operation for maintenance purposes, and may flow from the IT organization to the ICS via strong firewalls for purpose of performing update to the system. So what kind of defenses we are doing? First of all, in many cases, we cannot detect the attack specifically. So what we need to do, we need to have instruments which are performing anomaly detection. Anomaly means a deviation from normal operation. We need to have specific instruments which are monitoring the normal level and those which are detecting the changes from the normal level. This will allow you detecting unusual conditions, and good chances this will allow you detecting problems before a damage happens. So this is something very, very important. So when we speak about secure interconnection, not convergence about the network, but secure interconnection. First of all, we say that the networks must be separated. So if somebody is managing to attack one side, he cannot migrate to another side. OT teams and IT teams must collaborate, must work together, must be creative, must help each other. And why? Because we need to have business continuity planning, we need to have disaster recovery preparedness, and finally, we need to have incident response operation. Very, very important, this collaboration among team, helping each other, and so on. So what kind of instruments we are using? All of us are familiar with the firewalls. The firewall is some kind of appliance which you can program to specific rules. You program it which IP address can communicate with which IP address. You program it about data which can flow or cannot flow, and so on. I'm not going to go details. All of you are familiar with firewall. This is the basic cyber defense. But firewalls are software-based defense. You must remember that every software-based defense can be compromised. This is very, very important. So there are a set of functions which the firewall cannot help you. If a malicious insider is bypassing the firewall somehow, or internally generated attack, or a broad range of internal attacks created by internal people, by service provider, by supply chain. In all these cases, firewalls really cannot help you. The other cyber defense is the DMZ, demilitarized zone. It is acting like a firewall, but in reality, we have two firewalls, and the whole idea is that data cannot flow from one side to another. It must go through a demilitarized zone. In that zone, some changes to the data can be done. A protocol translation, a historian, storage of data, broad range of activities. So the idea of the DMZ, you cannot go from left to right directly. You must go through the demilitarized zone. You cannot go from the right side to the left side. You must first go to the demilitarized zone. Sometimes we see the demilitarized zone between two countries. It's like a space of it may be 1 meter or 100 meters, which is where inspection is being done. So the name demilitarized is coming from the crossing, the border crossing between two countries. Another cyber defense mechanism is the data diode. The data diode is a very strong cyber defense mechanism because it allows data flow only in one direction from the optical transmitter to the optical receiver, and no data can go from right side to the left side. You remember I said every software-based defense can be compromised. So you must remember that because the data diode is built on a physical devices, optical transmitter, piece of fiber, and the optical receiver, it means that it is a physical defense and not a software-based defense. There is a broad range of suppliers of data diodes. You can select it according to performance, according to price, according to protocols, whatever is correct for you. Another advanced solution is the security information event management. It is a kind of software which is collecting data from a broad range of appliances in your organization. It is correlating the data from all these appliances, reaching a conclusion, and the conclusion is being forwarded to the Security Operations Center, the SOC room, and people who are sitting in the SOC room are receiving information from many information sources, including from the SIM, from the government organization, from the news media. They get a lot of information and they are capable of correlating all this information in order to generate an alert when something is happening. So in a major organizations in all countries, we already see that people are using the SIM and the SOC operation. And if you don't have that, obviously you must plan for that. So what we need to do, we need to be ready for a moment that cyber can occur. See what is written on the right side. Then the note, if you not assume that you are targeted or can be targeted tomorrow morning, and you not start searching for the attack, you will never find it. And what does it mean? You might be surprised with the outage, surprised with the explosion, supply with major damage, supply with risk to lives of people. So we need to take actions. We need to have strong documentation about our organization. We need to be prepared for what we need to do. And when it happens, we must have a plan. How are we going to react? And this is I want to repeat, this is the responsible of the top management in every organization. So how can we assure all these goals? I already said that training is very important. For example, you may consider a training which can be done in 4 meetings during 16 hours, a very short training, but meaningful training to acquire the needed knowledge. This training is suitable for operators. It is suitable for engineers. It is suitable for IT people who must learn how to protect industrial organization. It is definitely recommended. It is short. It can be done in 2 weeks. It is affordable, and you can definitely consider it for your organization. In this session, you will learn introduction on ICS for those people who may not know this profession. You need to identify the different components which are installed in the organization. You need to learn the principles of design, about how to design or how the industrial operation was supposed to be designed in order to assure operating safety and reliability. In the second meeting, it can happen in the same week, we are already going to dive deep into the cybersecurity topic. We will talk about system architecture, the differences between IT and ICS. Talk about the vulnerabilities. Vulnerabilities are those problems which allow the attackers to penetrate to our facility. We'll talk about different range of attacks, many in the middle, denial of service, distributed denial of service, sabotage, GPS, ransomware. We'll talk about all these attacks. And at this meeting, we will talk about the coordinated safety and cybersecurity considerations. Why? Because our goal is always to achieve operating safety and reliability. This is the goal for industrial organizations. We are not worried about confidentiality. We are not worried about if the data is 100% accurate, if it's not affecting safety. It's not a bank. It's not a credit card. It's the industrial operation where safety is the top priority. In the third session, we are going to talk about attacks. How actually the attack is happening. We talk about the industrial cyber kill chain, about the Mitra attack process. We will go through demonstrating step by step how an attack is happening. We are going to talk about all these things, and remember, the goal is always to assure operating safety and reliability. Then we are going to talk furthermore, we are going to talk about the defense measures. Sorry, I made a mistake. Each session that is described here is 2 hours. So on one day we will have 4 hours. We will cover 1, 2, 3, 4, and so on. On session 5, we are going to talk about the defense standard. What is happening in Israel? What is happening with the 62443 standard? What is happening with cybersecurity assessment? How to perform assessment according to the 62443 standard. We talk about the Shodan IO, how people can detect your organization which is not properly protected. I already mentioned here briefly, but we will go deeply to the BCP, DRP, and IR processes. We'll talk about exactly what needs to be done, how each of these processes must be trained. We will talk about principles of cyber secure system design. All these things will be covered. You will have a lot of information I didn't mention, but this entire workshop will have about 350 slides, 350, which the participants will receive, and we will be able to use them in their organization in order to further learn. We will talk about the forensic. The speaker before my session was talking about the forensic, but I'm going to talk about practical actions which internal people in the organization must do. Finally, in the last 2 sections, we will talk about unsolved vulnerabilities, those vulnerabilities which are sitting in your organization, best practices, how we are going to protect buildings, data centers, communication network, how we are correctly performing cyber-secure maintenance for the organization, electricity, oil and gas, water, power generation, power distribution, how we are maintaining these facilities, and remember what I always said, assuring operating safety and reliability. Earlier, I talked about the couple of cyber attacks, and we are going to deeply explain how these attacks happened. What kind of vulnerabilities contributed to each of attack? How each of these attacks could be prevented? Then we are going to talk about the technologies. What next? What is coming? How artificial intelligence, machine learning, advanced technologies are going to contribute to the operating safety and reliability. We will do some short simulation program of an incident, how we are responding to the incident. Finally, Q&A, and we will have also a short examination, couple of questions, not too complicated, that you will receive. Finally, after that workshop, you will receive a certificate that you participated in the 16-hour workshop specifically tuned for industrial control system and IIoT is cyber security. So briefly, what is happening to your organization when the attack will happen? A broad range of administration and legal costs that you have to deal with them. Post-incident cost. Media will ask questions. Investors, call centers will receive questions. Cost of forensic, purchasing new equipment, restoring the operation, losing business opportunities. If you are not supplying a product, other organizations will supply and you lose business. Finally, what I mentioned earlier about the ISO 27001, personal reputation of the top management people, the CIO, CISO, CEO, all the people who are sitting in the top floor of the organization really must be worried. So summarizing, what does it mean collaboration between the teams? We already talked about that the networks are not converging, but the data is converging. So the air gap was until 2010. Since then, data must flow from ICS to the IT, and the different teams must receive all the information in the very short time. The collaboration must assure that the programs can be securely updated without allowing an attacker to penetrate to the facility. So as you see, it's really a real story. Industrial control cybersecurity is a role for experts. It's not a role for IT people who never learned ICS cybersecurity. It's not for ICS people who never learned cybersecurity. It is roles for experts who acquired that knowledge. Finally, I would like to summarize my short session before we go to the Q&A. And take these messages. Put security and safety goals to your specification. Deal only with vendors who take operating security and safety seriously. Do not compromise on critical requirements. If they are in the specification, make sure that these are answered. Always be ready for tomorrow's challenges. On this slide, you have my phone number, you have my mail. you can obviously start with contacting Mr. Gilbert, who invited me to this presentation. And not forget to ask for copies of this presentation, because this is the only way how we can enhance the cyber secured operation of your organization. Thank you very much. And I think we have plenty of time for questions and answers, but those questions which may arrive late will be answered via the email.